Okay, in this example we have a function that's again written implicitly. Now it would be possible to solve this for y. You end up getting two equations. Y is plus or minus the square root of 9 minus x squared. Alright, when you can proceed to differentiate both of those. And hey, I encourage you to go ahead and try that. But here, implicit differentiation is so much nicer. So we start by differentiating both sides with respect to x. And we do that when we differentiate x squared with respect to x, we just get 2x. But when we differentiate y squared, because of that little difference there, we have to invoke the chain rule and say, well, it would be the derivative of y with respect to y times the derivative of y with respect to x. And derivative of 9 would be 0. And then we want to solve for dy dx. So subtract 2x from both sides. And then we can divide by 2y. And we get negative x over y. So here dy dx is defined in terms of both x and y. Now rather than continue and say, hey, let's figure out what that is in terms of just x, or even trying to do that, we're not going to worry about that here. We're just interested here now in finding dy dx. This time it's expressed in terms of x and y. Now as a further illustration of this problem, and what this can still allow us to do, even though now we're dealing with an equation it is not a function. Alright, take a brief moment and recall what that equation is. Right, that's an equation of a circle centered at the origin with radius 3. Now even though we do not have a function here, we can still talk about finding the equation, or at least the slope of the tangent line. At 1, 2 squared is 2. Now, quick confirmation shows us that yes, this is in fact a point on that graph. Plug in 1, you get 1 squared, 2 squared is 2 squared, would be 8, 1 plus 8 is 9. So we'd like to find the slope of the curve at that point. Be negative x over y. 2 squared is 2 over 2. We'd like to rationalize that, of course. So multiply by the square root of 2 over 2. Get negative square root of 2. And in the bottom, square root of 2 and square root of 2 would be 2. So square root of 2 over 4. So working it out as a decimal, you'll find that that's approximately negative 0.35 or negative 1/3. I've actually drawn a picture of what we found here. There's our tangent line going in, and just for reference, I've drawn two lines over here. First, this line right here, it has a slope of negative 1. Just for reference, you can see that it's much steeper than our line. And then a slope here of negative 1/2. Again, just for reference, so you can see that our line again is even flatter than the negative 1/2. So visually, the picture does kind of coincide or confirm our answer of a negative 0.35. A little bit more than negative 1/3. Alright, so again, that's just taking what we found now and using it. We found our derivative. Now we're using it to find the slope of the curve at some point. Again, even though this is not a function, it still works that it tells us the tangent line. Okay, it's telling us the slope in terms of x and y.